Okay, so why did the data analyst cross the road?
Oh boy. Um, I don't know. Why?
Just to get to the other data set.
Wow. Okay. That's really something.
Hey, look, I had to set the tone right. Because today we were getting into some seriously heavy data concepts. But welcome to this deep dive, everyone. I want you to imagine something for a second. You are sitting on an airplane, zero Wi-Fi.
None at all.
Exactly, you're totally disconnected. And you decide to try and crunch like 50 million rows of raw sales data directly inside a single Google Chrome tab.
Right. Which a few years ago, doing that would have literally melted your laptop.
Oh, totally. You'd hear the fans spinning up like a jet engine and then everything would just freeze. But today, that is just another Tuesday using the Analyze module in datok. So our mission for this deep dive is to get you completely comfortable with this massive toolkit.
Yeah, it's a lot to unpack.
It is. We're going to master building pivot tables from scratch. We'll talk about organizing chaotic data structures, without losing your mind. And ultimately, we are going to unlock the math behind fixed level of detail calculations.
Ooh, which sounds intimidating, I know, but it is incredibly powerful.
It really is. But I think before we get into the advanced metrics, we have to establish what this environment actually is. Because the Analyze module, it fundamentally flips the script on how enterprise data tools normally operate.
Okay, how so?
Well, this is a highly responsive, entirely local environment. I mean, you are summarizing millions of rows visually without sending a single byte of your data to a cloud server.
Wait, let me stop you right there, because when you say we are processing millions of rows inside a browser tab, my brain just immediately flashes back to, like, my browser crashing because I had too many news articles open.
Right, the classic memory hog.
Yeah. So how does a standard web browser handle enterprise-scale data locally without just instantly collapsing?
So it uses something called OPFS. That stands for the Origin Private File System. Origin Private File System, okay?
Yeah, it's a relatively modern web standard,
Yeah.
and it basically gives web applications high-performance access to a private sandbox file system directly on your local device.
Oh, I see.
So instead of trying to load, 50 million rows into your limited active browser memory all at once, datok uses OPFS to read and query the data straight from your hard drive.
Really fast, I assume.
Incredibly fast. It essentially gives you unlimited data scale, completely untethered from the internet.
Okay, so the hard drive is doing the heavy lifting, not the cloud.
Exactly.
That sets the stage perfectly. But to actually extract any kind of insights, we have to put our pieces on the board, so to speak.
Okay.
Because the core of this Analyze tab revolves around a drag and drop pivot builder interface. You've got your dimensions and you have your measures.
Right. And for anyone who's transitioning over from standard spreadsheet software, the user interface will feel very familiar. But the execution happening under the hood is built for a completely different magnitude of data.
Okay, let's unpack this. I like to visualize it like setting up a chessboard.
Oh, I like that.
Yeah, so the dimensions, these are your categories. Things like region, country, customer segment, they represent the actual squares on the board.
They give the grid its structure.
Right. They provide the layout. Then you have the measures, which are your numerical fields, sales, profit, quantity. Those are the actual chess pieces. They're the elements battling it out and doing the heavy lifting on the grid that you just defined.
That is a great analogy. And once you set up that board, datok gives you a really simple one-click grand totals checkbox.
Oh, that's handy.
Yeah, it instantly calculates and appends summary rows to the bottom and the right edges of your pivot grid. But, and this goes back to your earlier point about browser limits, this is exactly where we need to ground the conversation in hardware reality.
Uh-oh, here comes the catch.
Well, it's just physics, right? OPFS handles the raw database storage beautifully. But the pivot grids themselves, like the final summarized numbers you're actually looking at on your screen, those are loaded directly into the browser tab's active sandbox memory.
And that sandbox memory is definitely not infinite.
Far from it. The JavaScript heap memory, which is what your browser uses to render the active tab, typically maxes out somewhere between 1.5 and 4 gigabytes of RAM.
Okay, so 1.5 to 4 gigs.
Yeah, and that ceiling depends heavily on your specific system architecture, your browser settings, things like that.
So let's define that boundary clearly for the listener. Say I get a little too ambitious. I drag like 12 dimensions onto the board and try to pivot all 50 million rows at once.
You're going to hit that limit.
Right, I'm going to hit that 4 gigabyte ceiling pretty quickly. What actually happens? Does the whole application just brick itself?
You will exhaust the memory and the tab will crash. Yeah, you'll just receive a standard out-of-memory error.
See, that terrifies me because in legacy tools, A crash like that usually means hours of complex formatting and data merging are potentially just gone. Poof.
But that is the brilliant part of this specific local architecture. Your underlying data is perfectly safe.
Oh, really?
Yeah. Let's think about it like a physical workshop. Your hard drive, the OPFS storage, is your massive warehouse.
Okay.
And your browser tab is your physical workbench. Now, the workbench can only hold 4 gigs of material at one time before things start falling off the edges. If the workbench collapses under the weight, your warehouse is still perfectly intact.
Okay, I love that. So the local database file sitting on my machine is not corrupted by a memory crash in the UI.
Exactly.
I just, refresh the tab, set up a slightly smaller workbench, and pull the data again.
Precisely. You just refresh the page, maybe jump back to the prep module to filter the dataset down to a specific fiscal year first, and then build the pivot again.
That completely removes the anxiety of permanently breaking your primary data source.
It really does. It frees you up just to explore.
That is a massive relief. But honestly, even if you avoid crashing the tab, you can still totally crash your own workflow if your workspace is a disaster.
Oh, absolutely.
Because once you get a dozen dimensions and measures loaded into a project, that sidebar can become a chaotic mess so fast.
If your sidebar is disorganized, your analysis will inevitably suffer. I mean, it becomes impossible to find the signal in all that noise.
Right. And I noticed there's a surprising amount of power hidden simply by right-clicking these fields in the sidebar.
Oh, yeah. The field actions.
Yeah. For example, duplicating fields. You right-click a metric, hit duplicate, and datok instantly creates a calculated copy appended with an auto-incrementing suffix. So you get, field 1, field 2, field 3.
And why do you think that specific simple feature is so critical for a data analyst?
Well, because it allows for completely non-destructive experimentation. Like, if I want to test a highly complex new tax calculation on my sales data, I do not want to overwrite the original sales column. By duplicating it, I get a little sandbox version of the metric. If my math is entirely wrong and the metric breaks, I just delete the copy, and the original column is sitting there untouched.
It encourages curiosity. You are much more likely to look for deep, unconventional insights if you know you cannot accidentally destroy the primary data set in the process.
I completely agree. But let me challenge the system's resilience here for a second.
Bring it on.
Let's say I am working incredibly fast. I'm just dragging and dropping stuff everywhere. And I accidentally grab a purely text-based dimension, let's say customer name.
Okay.
And I drag it directly into the measures field. I am literally asking the software to perform mathematical operations on a word.
Right.
Now, in most SQL environments, a type mismatch error like that brings everything to a grinding halt. Does datok throw an error, or does it just freeze?
It's a very valid concern.
Yeah.
But datok anticipates that exact user behavior.
Oh, it does.
Yeah. When you drag a non-numeric text dimension into a measure shelf, or if you use the convert to measure right action, the system automatically wraps that text field in a distinct count calculation. It creates what we call a count D field.
Oh, that is so clever. Instead of trying to add the names John and Sarah together, it pivots and just counts that there are 2 unique names present.
Yes. And if you realize, oh, wait, I made a mistake, and you drag it back up to the dimensions area, datok instantly deletes that helper calculation.
So it cleans up after itself.
Exactly. It keeps your workspace entirely clean without forcing you to manually write and erase SQL statements.
It feels very forgiving. And speaking of keeping things clean, those top-down dimension hierarchies are a fantastic organizational tool.
They're essential.
You can basically build these collapsible folders to group related fields together. You just use up and down arrows in the menu to define their relationship. So you place region at the top, country below that, and state below that.
And, that hierarchy is much more than just cosmetic organization for the sidebar.
What else does it do?
Well, it allows you to systematically drill down into your pivot tables. When you place a hierarchy on the board, you can expand or collapse the level of detail directly on the visualization itself.
Oh, so you don't have to go back to the menu.
Right. You are moving from a macro view to a micro view with literally one click.
I'm really glad you brought up the visual side, especially regarding geographical dimensions, because this was one of the most surprising parts of the local processing model for me.
The mapping.
Yeah. Usually, if I want to plot sales data on a map, the software has to ping some third-party server, send my data out through an API, and then wait for the mapping coordinates to come back.
Which fundamentally breaks the promise of a completely local, untethered workspace.
Exactly. If you're on that airplane, you can't make an API call. So how does datok handle mapping if it refuses to talk to the cloud?
What's fascinating here is that it handles it entirely offline through incredible built-in libraries.
Wait, built in?
Yeah. When you load a schema, datok automatically analyzes your column names and the values inside them against standard geographic databases. And specifically, it relies heavily on UN M49 standards.
Let's quickly clarify what that is for the listener. The UN M49 is basically the United Nations master list for geographical coding, right?
Correct. It's an internationally recognized standard for area codes, and datok uses that along with US subdivisions and standard ISO codes. Because that entire library is stored locally within the application, it can natively map full country names or even just three-letter abbreviations instantly.
Wow.
It just knows CHE is Switzerland without ever needing an internet connection.
And the visual output is not some blocky, basic 1990s graphic either. When you drag those geographical dimensions onto the canvas, it renders these stunning, dark mode interactive choropleth or symbol maps.
They look really premium.
They do. It uses this equirectangular world map base with extremely high-resolution boundaries. It basically proves you do not have to sacrifice presentation-ready visuals just because you are operating offline.
Absolutely. The visualization layer is vital. But okay, so we have our data safely stored via OPFS. Our workbench is organized. We can plot offline maps. Now we need to transition to the actual math, the aggregation.
The core of any analytical workflow.
Exactly.
And datok gives you the essentials the moment you click a measure. You have SUM, count NNT, average, minimum, and maximum. But let's be honest, standard absolute aggregations only tell half the story. Like, knowing the absolute total sales for a region is fine, but business questions usually demand context. I don't just want the total number. I want to know what percentage of my global business that specific region represents.
Context is where true analysis happens, and that is why the calculation dropdown, which is located right next to the aggregate type, is so vital. You are never locked into absolute numbers. You can instantly toggle a metric to display as a percentage of row total, a percentage of column total, or percentage of the grand total.
And changing that dropdown doesn't just update a single number in a grid, right?
No, it acts globally across the entire visualization layer.
Oh, nice.
When you toggle a percentage calculation, datok dynamically reformats your axes, your tooltips, and all the data labels on your interactive charts.
So it's totally seamless.
Yes. Whether you are analyzing a bar chart, a heat map, or those offline maps we just discussed, the visual context automatically updates to reflect the percentage.
That is super slick. But we have to circle back to hardware realism here for a second.
Okay, let's do it.
We talked about browser memory handling the display and OPFS handling the database scale. But when I ask a local machine to calculate the percentage of a grand total across 50 million rows, that math requires immense processing power.
It absolutely does. And the bottleneck in that specific scenario is rarely your CPU or your RAM.
Really? What is it then?
It is your disk read and write speeds.
Oh, the actual drive.
Yes. The speed at which datok can crunch complex aggregations relies entirely on how fast it can pull data from the SQLite file sitting on your drive.
Just for the listener, SQLite is the underlying local database engine datok is using behind the scenes.
Yes, exactly. It is a highly reliable, completely serverless database engine. But it is still limited by physics. I cannot stress this enough. Using a solid-state drive, an SSD, is absolutely critical for a smooth experience.
So no old hard drives.
Right. If you are running datok off an older, spinning platter hard drive, your queries are going to bottleneck at the physical disk level. I mean, the mechanical arm of the hard drive physically cannot move fast enough to feed the data to the software.
Right, because it's literally a physical needle scratching a disk.
Yeah.
So the rule of thumb is treat your hardware right, use modern solid-state drives, and the software will fly.
Exactly.
Okay, so basic percentages give us great context. They tell us our slice of the current pie on the screen. But I want to push this further. What happens when a business question demands a percentage based on a level of detail that is completely different from what is currently visible on your screen?
Well, now we are crossing the threshold from standard pivot tables into advanced data science logic.
Here is where it gets really interesting. This is the feature I have been most excited to discuss. Tableau-style, fixed level of detail calculations, or LODs.
It's a big one.
This concept is notoriously intimidating for analysts, but once you grasp it, it completely alters how you approach problem solving.
It separates a basic spreadsheet from a professional analytics architecture. Historically, doing this kind of multi-level aggregation in legacy SQL required analysts to spend hours writing incredibly complex joins and nested subqueries just to find a denominator.
Just for one number, so let's try to demystify it for the listener. I like to explain a fixed LOD calculation using a camera analogy.
Okay, let's hear it.
Imagine your main pivot table is a ground-level camera. It can only see what is physically placed directly in front of it based on the dimensions you drag into the rows and columns.
Right.
So if you drag the dimension city onto the board, that local camera is heavily restricted. It only sees city-level data.
It is completely constrained by the local environment and whatever filters you have applied to that specific page.
Exactly. But a fixed LOD calculation acts like launching a drone camera. While your ground camera is stuck staring at a specific city, you can program this drone to fly high up, look at the total sales for the entire region, calculate that massive macro number, and then project that regional total back down onto your ground level view. So your local camera can now see its own small city sales and the massive regional sales right next to it simultaneously.
That drone analogy works perfectly because it highlights the actual mechanism. The drone operates completely independently of the ground camera's filters.
Oh, that's a key point.
Right. If a user filters the city view to only show data for December, the drone up in the sky does not care. It still calculates the full annual regional total unless you specifically program the drone otherwise.
But wait, how does datok actually process that without double counting everything? If the drone is ignoring the local filters, there must be a very strict set of traffic laws governing what calculation happens first.
Yet to make this work without crashing, datok relies on a strict execution pipeline. If we connect this to the bigger picture, it doesn't calculate everything at once. It happens in sequential stages.
Okay, walk me through the stages.
Stage 1 is row-level math. If you have a basic formula, for instance, taking the sales column and multiplying it by 1.2 to simulate taxes, datok computes that math on every individual row in the database first.
Simple enough. That's like calculating the tax on every single physical receipt in a shoebox before you do any sorting or reporting.
Exactly. Only after those individual receipts are finalized do we move to stage 2, and this is where your drone launches.
Okay, the LOD stage.
Right. The fixed LOD expressions evaluate. datok groups the rows based on the exact dimensions you specified in your LOD formula. It computes the macro aggregate, and then this is the crucial mechanism. It writes that macro result back onto every single underlying row as a brand new column behind the scenes.
Whoa, so the drone takes a picture of the regional total, flies down, and physically stamps that big number onto every single city receipt belonging to that region.
Yes, it bakes the macro insight directly into the micro-level data. Then we move to stage 3. This is when the standard pivot table dimensions and your local ground-level filters are finally applied.
Ah, I see. Because the LOD drone did its job in stage 2, it completely ignores the local filters applied in stage 3. The number was already stamped on the receipt before the filter ever touched it.
Precisely. And finally, stage 4 is when the standard pivot measures are aggregated and rendered on your screen. The pipeline guarantees mathematical consistency.
Let's ground this in a tangible, real-world example so the listener can really see the value here. Let's say you were looking at retail data.
Okay.
You want to calculate the percentage of total sales that each subcategory, like bookcases or chairs, contributes to its parent category, like furniture.
Which is a very common business question, but surprisingly difficult to answer dynamically in a standard pivot table without cluttering the screen with grand totals everywhere.
Right, because if you only put subcategory on the board, the system only knows the sales for bookcases. It does not know the total sales for all furniture to use as the denominator.
Exactly.
So, step 1, we deploy our drone. We create a fixed calculated field. Let's name it category total sales. And the syntax is incredibly simple. You write the word fixed, bracket the dimension category, colon, SUM of sales.
And by executing that, datok scans the entire dataset, finds the total sum of sales for all furniture, and stamps that massive total onto every single individual row that belongs to the furniture category.
It does the same for technology, office supplies, everything.
Right.
So now every single row knows its own individual sales and its parent category's total sales. That makes step 2 incredibly easy. You just create a second calculated field for the percentage. You take your standard row level sales and divide it by the new category total sales field you just created with the drone.
And because of that strict execution pipeline we talked about, you can now drag category, subcategory, and your new percentage metric into any visualization. You get incredibly deep, normalized insights.
It's just right there on the screen.
Yeah, you can clearly see that bookcases make up 20% of all furniture sales. And you can do this without building complex SQL joins outside the software, or relying on a cloud server to crunch the subqueries.
That is the part that blows my mind. You go from simply reporting numbers on a grid to generating deep relational insights. You are telling a complex story about how microcomponents relate to macro trends, and you are doing it by writing drone camera LOD formulas, generating dark mode interactive maps, and crunching 50 million rows entirely inside a local browser tab powered by OPFS.
It really forces a total recalibration of what a local machine is actually capable of.
It really does. So let's bring this all together. Today, you and I unpacked the Analyze module. We set up our workbench, learning how to structure dimensions and measures while keeping a close eye on our browser memory limits.
Very important.
We organized the chaos, utilizing right-click duplication for safe experiments and trusting the CountD safety net when our data types inevitably clash.
We explored how offline UNM49 mapping libraries deliver premium visuals without ever making an API call. And we defined why solid-state drives are absolutely non-negotiable when you start running complex percentage calculations.
And finally, we launched the drone. We mastered fixed level of detail calculations to pull massive macro insights down into our micro-level views, leveraging a strict 4-stage execution pipeline to keep the math flawless. You are no longer just manipulating spreadsheets, you are architecting data logic. So as you prepare to load your next dataset into Datok, what is the big takeaway here?
Well, I think this technology raises a profound question that challenges the current software landscape. If a fully local, browser-native workspace can process intricate level of detail queries, map global coordinates instantly, and pivot tens of millions of rows by directly leveraging your local hard drive, how much of our everyday enterprise cloud computing is actually just unnecessary, wildly expensive overhead?
Wow. That really is the ultimate question. Maybe the drone does not need to beam its data to a server farm halfway across the country. Maybe it just needs to land right back on your desk. Thanks for taking this deep dive with us.